Assalamualaikum warahmatullahi wabarakatuh and good day to the respected jury and fellow audiences. My name is Muhammad Zaid bin Abu Bakar from Sultan Idris Shah Polytechnic, and I'm here to share with all of you about the ESP32 base shield board that we have developed. ESP32 base shield board, as the name suggests, is ESP32 compatible board. It was designed and developed to overcome certain issues that we face during the implementation of the new course, the DEC50132 Internet-based controller. It is also a useful platform to test our codes without having to connect to other devices. Conventional method of stacking ESP32 microcontroller directly onto a breadboard will reduce the availability of the GPIOs to a single row or limited to just one side of the ESP32 microcontroller. It is also observed during circuit troubleshooting that students often had difficulties to figure out whether the problem lies in the electronics or programming parts of the system. So to address these issues, the team decided to design and develop a base shield board compatible with ESP32 microcontroller with built-in SMD LEDs tied into different general-purpose input-output pins. Thanks to its double-layer PCB design, the ESP32 base shield board proved to be compact, lightweight, and durable. The board is also equipped with 25 SMD LEDs for its input-output pins, 30 male pin heads for ESP32 pinout, and 8 male pin heads respectively for its 5-volt supply, the 3.3-volt supply, and also for grounding purposes. The base shield board that we present today is the result of continuous improvement process. The team follow a strict production process that includes designing the schematic, generating PCB board file, arranging components, routing, adding silkscreen and copper pores, and lastly, error checking and generating Gerber files. To help with the production process, the team uses the free version of Eagle and Fusion 360 software by Autodesk. Eagle is an electronic design automation software that lets printed circuit board designers seamlessly connect schematic diagrams, components placement, PCB routing with comprehensive library contents. But first, it is wiser to just download the symbols and footprints for the ESP32 DevKit microcontroller from SnapEDA. SnapEDA offers free library of symbols and footprints for millions of electronic components. Once the library had been downloaded, it is placed in a specified folder. Next is to tell EagleCAD where to look for the library. The location path is modified to tell Eagle exactly the folder location and name where it will find the library. If done correctly, a folder with the library will show up. The PCB design process started with the schematic of our circuit. First, search for the required components and place it onto the workplace. It is best to place all schematic symbols on the workplace canvas before drawing any wires. This schematic will serve as a blueprint for laying out the traces and components on the PCB. The next process is to wire up all the components used in the project. These wires will become the traces. A completed schematic is then converted into a PCB layout consisting of components, footprints, and red lines. Red lines refer to electrical connections that have not yet been converted into physical connections. The next process is to arrange components and then uses the red line as a guide for creating traces, copper pores, and vias. A via is a small through hole that carries an electrical connection to a different PCB layer. Double-sided PCB design employed in the innovation will allow a higher density of components and increases heat dissipation. This is the pad where components are being soldered to the board. Once the design process is completed, in Eagle, the last step before sending it off to the fabrication house is to generate the Gerber files. Then the Gerber files can be uploaded to the JLC PCB website. Upon receival, the PCB is thoroughly inspected for defects. Components are then mounted and soldered. As the direct impact, all ESP32 pinout is now accessible. Circuit tidiness is better. Indicator LEDs makes troubleshooting process much easier and thus reduce the amount of time needed for troubleshooting and circuit assembly. Let's hear what the student
Saya membuat practical work menggunakan portable ini. Ia adalah lebih kompleks dari segi pemasangan dan juga kita mudah untuk melakukan kesilapan ketika membuat pemasangan. Manakala ketika kita membuat practical menggunakan board ini, ia adalah lebih cepat dan lebih mudah dari segi pemasangan.
Pada practical work, project board menggunakan banyak penggunaan jumper wire. Manakala untuk innovation board, kurang penggunaan jumper wire. Untuk project board, kita sukar untuk melakukan troubleshoot. Manakala untuk innovation, kita senang untuk melakukan troubleshoot kerana setiap pin mempunyai LED yang berfungsi sebagai indikator voltan pada setiap pin.
Thank you everyone. Assalamualaikum.